Okay, my name's Stephanie Smith and I'm a TAFE teacher at Acacia Ridge. So I teach fitting and machining. So for me, the Smart Manufacturing Lab it's a really good way for basically across campuses to actually start working collaboratively with each other, which needed to be done. It's fantastic that we're starting to do it now. And actually going forward with our manufacturing space. Obviously, we still have your normals, your manual machinings and things like that, which still are very valid in this day and age, but we also need to push that envelope and start actually catching up with industry. And this is brilliant. This is the way we need to go. And I love the fact we're actually doing it now. And it allows us, again, like I said, to do things remotely. So I don't know, I just love the fact we are pushing that boundary now and actually starting to teach this to the apprentices and start teaching it to school students, and they can understand why we do what we're doing. So yeah, for me, I think it's fantastic. For me, more the collaborative work with other campuses, because you get to start to know other teachers that you wouldn't normally actually deal with. Yeah, I love it. I do love it. I really do love it. It's quite nice because I've been chatting to the apprentices that I have at the moment about what they've got over here, and they're going, oh, that's so cool. I said, yeah, the robots do the loading, you do, and everyone goes, oh, he's taking our jobs. No, your jobs are just changing. You're not the loader person anymore. You're now the programmer of that robot, sorting the loading out and fixing that bit of it. I said, so you just step back away from the dangerous side. I said, it's fantastic. I said, I think it's the way to go. But so CNCs, okay, so for those who don't know, CNC stands for Computer Numerical Control. If you really want to see how CNCs can really smash themselves up, there's always CNC fails on YouTube to have a look at. But the main thing about them is it does everything that a manual machine would do, so lathes or mills, so we can obviously do that. But the difference is we've got now what we call repeatability. So I can do 100 jobs and they will all come out exactly the same without any variance, and we can do it very quickly. So as a teacher, what we do, we teach the apprentices on how to set the machines up so they don't smash themselves up. So making sure they've got, because we have to have separate tools and this, that and the other, so all the tool lengths to put in, we have to make sure they basically have to tell the machine where the job is on the bed of the machine, so it needs to know where it is so it can do what it needs to do. And they also write the programs, so they have to do it from start to finish, so it knows where it's going, what speeds the spindles are running at, what feed rate, so how quickly we're running past the jobs. All of that, they have to program all on that, so it actually gets the part out accurately in really good condition, basically, or really good surface finishes all over it. And once they do that, if they'll measure it, check see if there's any errors, they can adjust then in the background of the program. So it's a thing called the offsets. We can adjust the offsets to make it so it comes out as a perfect part. And then it's just keep going, keep loading. And then that's where you start checking like 1 every 10 or 1 every 20 and make sure that it's still running how we should. And then a tweak and adjust or change tooling if we need to. But yeah, the actual programming of it, it's like learning another language. But once you get it, it's really weird when you're teaching apprentices it and they've never done it before, all of a sudden you just see the light bulb come on. I said, I promise you you'll just go, oh, is that all it is? Yeah, that's all it is. And it does, and it is literally like a light bulb moment. You see them go, oh. And they're really good, and then all of a sudden they're away, and you're like, brilliant, they got it. But yeah, it's really good. Once you get them doing it, there's nothing they can't do. It's fantastic, I love it. So the Haas's we have, so the nice thing about the Haas that we have, it runs on what we call ISO coding, which is a very generic coding that is used all over the world. So at TAFE we teach how to ISO code. There's other ways to code, which is like what's called conversational. So in the background, the machine still needs this ISO coding, or G coding as it's called. But in the front, it's done so that it's more of a conversation you have with the machine. So it goes, what size do you want to make it? You want this size. How long does it need? It needs to be this. What tool do you want to use? I want that. And it writes the program for you. You still need to understand the G code behind it, because if you need to go back and change something, you need to know what you're looking at. And I've had this argument with apprentices all the time about this. I don't know, I need to know this. You're like, oh, you do need to know this. So there's, like I said, there's conversational. Like I said, the nice thing about the Haas is it does have a conversational in it, which has got quite a lot of like little videos and little images to show you what it's actually asking you, what you're asking for. And you go, oh yeah, I'm asking for that one, which is really nice for when you start getting started. But like I said, then we start getting them from that, then they go into actually just coding without the little pictures, so they have to try and visualize what they're trying to do. And then obviously from that, you can go into what we call CAD CAM. So from a model in a CAD program, we can then do what we call a CAM, so it's computer aided manufacture. We can actually put all the toolpaths and program the toolpaths on a computer, convert it into a program, and then upload it into the machine, and it should still run. So there's multiple ways we can do it, and we do actually teach them all, so it's quite nice.